Read the question carefully. So we can say the starting point for the projectile is at the origin here, and the angle of elevation is 60 degrees, and it is fired with an initial speed of 200 meters per second. Now we need to find the range of the projectiles. So here to here, this distance from here to here, that's part A. The maximum height reached, suppose it reached here, so this height, maximum height, and the speed at impact. So when it hits the ground back, so what is the speed at that time? Okay, and we have derived the following formula in class. The position of a projectile at any time t is given by this formula. In part A, so let me simplify this here. So the position st is, because we have initial speed, that's 200, and we have angle theta 60, so this is 200 t cosine 60 degrees, which is 1/2, times comma, second component is p naught 200 t times sine theta, theta is 60, sine theta is √3/2, minus 1/2, g is 9.8, so half of 9.8 is the approximate value anyways, of 4.9 t squared. Okay, for part A, we're going to find the range of the projectile. So here is this distance, and we know that when this goes all the way up, goes down, then the vertical component, okay, is 0. I mean, it's just on the ground again, so the vertical component is 0. So this is x, that's horizontal, this is vertical, so we set this equals 0 to determine how long it took, okay, to determine the time. So we set this equals 0, 200 t times √3/2. We should have simplified, but we'll do in a moment. From these two we can factor t out, so 200 √3/2 to 100 √3 minus 4.9 t equals 0. So t, either t0 or this quantity 0. t0 means at the beginning, yes, it's on the ground, but we want to find the time when it is on the ground again. So that is 100 √3 minus 4.9 t equals 0. Move this over, divide by this. Okay, so t equals 100 √3 over 4.9. So let's not simplify. So we determine the time required by the projectile to hit the ground. That means we can now find the range. The range means this direction, the x direction. That's the first component. Thus, the range is, this is 200 times 1/2 means 100 t. 100 times, we just found the time here, 100 √3 over 4.9. Use calculator, we get in meters. Okay, so the range is 3534.8 meters. In part B, we have to find the maximum height reached by the projectile. Okay, so here this is like y component. Now we have two options. We just figure out this time. Look at here in part A. This is the time needed to get all the way here. That means to get to the top, how much time is required? Half of this. Just divide this by 2, which is same as multiply this fraction by 2 on the bottom. Or we can look at, we can differentiate this y component. This is position, so this is a vertical component, and if we differentiate this, we get vertical component of velocity. Position derivative means velocity, and we can set the derivative 0 and solve for t, because at the maximum height the velocity is 0, and find the derivative, set it equals 0, you find the time, which will be in fact just half of this. Okay, so I just want to find the time for max height. The time will be half of this. Just divide by 2 means multiply by 2 on the bottom. 4.9 times 2, 9.8. Okay, now we want to find the height. That's the y component, which is given by this formula. Okay, this is x component, this is y component. So max height is just 200t times root 3 over 2. 2 goes 200, 100 times 100 root 3t. 100 root 3t is here. 100 root 3 over 9.8 minus 4.9t squared. 4.9t squared. 100 root 3 over 9.8 squared. Now use your calculator, you get that many meters. Okay, so it comes out to be as 1531 meters. In part C, we are asked to find the speed at impact. When this projectile hit the ground here, so what will be the speed, just the magnitude of the velocity. Okay, we know the time here in part A. This is the time needed by the projectile to get to this place. Now we need to find the velocity at this time. First find the velocity and we just find the magnitude. Look at the position here at the beginning. That this formula gives us the position. First one is, that's the horizontal distance, this is vertical distance, and if we find its derivative position, then we get the velocity. So let's find the velocity here, finding the derivative of st. To find the velocity at impact, okay, or speed at impact, in fact, the magnitude of velocity. So we find the derivative of this position function. So this is the position function here, given by formula. And now we find the derivative of this position, and here is the velocity. Now we know it takes this much time to get to that point, so replace t by 100 root 3 over 4.9. So velocity at this time is this, which simplifies to 100 comma negative 100 root 3. Now to find the speed, we need to take the magnitude of this. Okay, so the speed at the impact, speed on the impact, or it says what? Speed at the impact. Okay, speed at impact is just find the magnitude of this velocity. Velocity at 100, this is time by the way, 4.9, which is square root of first square plus second negative 100 root 3 squared, and use your calculator, and it comes out to be 200. Okay, that's meters per second. Final.